Good morning guys and welcome to my channel Mind Your Math. Today we are going to do the first chapter of grade 8 which is rational numbers. So as usual with any chapter we will do a small introduction, then I will give you the basic definition of rational numbers and the properties related to rational numbers. Then we learn how to mark the rational numbers on a number line, and then we apply the properties of rational numbers to practical problems so that you get a clear understanding of why we are studying about rational numbers and how to apply them to sums. Now, if you are having any doubts regarding the concept that I am explaining today, you can drop a comment in the comment box or you can mail me at the mail ID given below in the description box. Before we learn what rational numbers are, let us revise what are the basic number systems or the types of numbers that we have studied so far. As small kids, we start with learning counting numbers. We learn counting by counting the number of objects that are easily accessible to us. So we learn basically from counting the number of toffees, the number of books on the table, number of pens, the number of pencils. So we start from counting 1, 2, 3, etc. And thus we learn about counting. And those counting numbers, mathematically, we know them as natural numbers. They start from 1 and they go up to infinity. Now that is another concept that you study, that the numbers are infinite. You cannot find the last number. So we say infinity is a concept nobody has discovered. Okay. To the natural numbers, if we add a 0, we get the whole numbers. So if somebody asks you what are whole numbers, you say the numbers starting from 0 moving up to infinity, they are called as whole numbers. Correct. Now while studying natural numbers, you study about fractions. Now fractions, you have a whole and then you have a part of it, and they gave rise to the idea of fractions. So mathematically, how do you define it? Any number represented in the form of a by b, where a is a whole number and b is a natural number. So why do I say b is a natural number? B cannot be 0. So b has to be a natural number and a is a whole number. So the value of a can be 0 to any number which we want. Correct. Then we learned about the decimal number system, right? Now in grade 7, you were introduced to negative numbers. So we call that number system as integers. So integers are basically the numbers from minus infinity moves up to 0 and then it goes up to plus infinity. So here you have a minus 1, here you have a minus 1, here you have a minus 2, etc. Now you have learned about the properties of integers, you have learned how to add integers, you have learned how to multiply, divide, etc., etc., and apply the concept of integers to certain word problems as well. So now, because we have learned about integers, automatically the next step in the number system are rational numbers. So let us see what exactly is a definition of rational numbers. So what is a rational number? The basic definition of rational number is something that you have to understand very clearly, because the conceptual understanding of any theorem or any new definition is very important. So this is very easy. Any number that can be represented in the form of a by b, where a and b are integers and b is not equal to 0 is called as a rational number. Now, a and b can be integers, means they can have any value including negative as well as positive. Fine. B not equal to 0, the reason is evident, because division by 0 is not possible in math. So such a number is not defined, right? That is what we say infinity. So we have no idea what that number is. So B cannot be equal to 0. So now that we are clear with the definition, can you tell me a few examples? You can say that 2 by 3, A and B are integers, B is not equal to 0, 2 by 3 is a rational number. 3, the natural number 3, is it a rational number? It is a rational number. I can represent 3 as 3 by 1. Okay. Now, is the definition of rational number complete? Let us check. 15 by 25. Is it a rational number? It is definitely a rational number, but is it represented in the proper form? Now, whenever you are representing a rational number, you have to ensure that this is in the lowest form, which means that the common number in the numerator and denominator have to be cancelled out, or I can write 15 by 25 as 3 by 5, because this is 3 into 5, this is 5 into 5, 5 and 5 gets cancelled, giving me 3 by 5. This is one important concept that you need to remember whenever you are representing a rational number or any number and saying it's a rational number. You have to ensure that the number is in the lowest form. Now, we have discussed about the lowest form of a rational number. There is another form of the rational number which is called as a standard form. Most of the times, the lowest form and the standard form, these two words are used interchangeably. So, sometimes in your school or in any of the classes that you attend, sometimes your teacher might say the standard form of a rational number or the lowest form of a rational number, like they are the same concept. There is a small difference between these two terms, the lowest form and the standard form. Let us see what it is. Let me explain it to you by taking a few numerical examples. Let us consider the rational number 11 by 121. You need to convert it into the lowest form and the standard form. So, cancelling out the common factors, you will get 1 by 11 as the lowest form. Now, is this the lowest form and the standard form? Yes. In the case of positive rational numbers, the lowest form and the standard form are the same. Right? Now, what happens with negative numbers? This is the lowest form. Is this the standard form? Yes, this is the standard form for this particular rational number. But if the rational number was represented in this way, you would write it as 1 by minus 11. This is the lowest form. But what is the standard form? You need to ensure that you are taking the negative sign from the denominator to the numerator. Normally, you know what we do? The students normally write it as minus 1 by 11, which is absolutely correct. But how did you get it? You are multiplying the numerator and denominator by a minus 1, thus giving us minus 1 by 11. You do not need to go through this step, but basically that is how we transfer a negative sign from the denominator to the numerator. Fine. So, this is a small difference that is there between the lowest form and the standard form only in the case of negative rational numbers where the negative sign appears in the denominator. Otherwise, both are the same. This is exactly the reason why these two terms are used interchangeably. So, you need to understand standard form is also the lowest form in all the cases. But in the case of negative rational numbers of this type, the lowest form and the standard form can be slightly different. Fine. So, when you are getting a number like this, in order to represent it in the standard form, reduce it to the lowest and bring the negative sign to the numerator. I have written a few rational numbers on the board. I have written a few numbers on the board. We have to identify which one of them is a rational number. If they are rational numbers, decide if they are represented in the standard form. And also identify which numbers are not rational numbers. So, 6 by 5. The numerator and denominator are integers. So, it is 6 by 5 is a rational number. Is it in the lowest form? Yes, it is in the lowest form. There are no more common factors between 6 and 5. So, therefore, it is in the standard form. Therefore, 6 by 5 is a rational number. Minus 3.5. So, it is a decimal. So, how do you identify whether this is a rational number? See, you need to understand that minus 3.5 is basically minus 1 into 3.5. Correct. Now, 3.5 is 35 by 10, or this is basically minus 35 by 10. So, since 35 and 10 are integers, or minus 35 and 10 are integers, I can say that minus 3.5 is a rational number. Now, is it represented in the lowest form? It is not represented in the lowest form. So, now let us convert it into the lowest form. So, this is minus 7 into 5. This is minus, so this is 2 into 5, or this is minus 7 by 2. So, I converted minus 3.5 into the rational number form, and then I have written it as minus 7 by 2. Okay. The next number that we are going to check is 3 by minus 7. So, both the numerator and the denominator are integers and they are in the lowest form. There is nothing common between 3 and minus 7. So, it is a rational number and it is represented in the standard form. But there is a small correction we need to make. 3 by minus 7, when you are representing it in the standard form, please make sure that you bring the minus sign to the numerator, thus making it minus 3 by 7. Okay, so it is just the basic representation of numbers. It does not change the value of the number or anything like that. So whenever there is a negative sign in the denominator, bring it up to the numerator and represent it in the standard form. 11 by 121. So again, both 11 and 121, they are integers. So it is a rational number. Now whether it is in the lowest form, so you very clearly know that this is not in the lowest form. This has a common factor. This becomes 1 by 11. And numerator and denominator are both positive. Now I have represented this in the standard form. Okay. Now 35. 35, as you know, is a natural number. It's an integer. So I can write 35 as 35 by 1. Therefore 35 is a rational number. Now, root of 36. You know the value of the square root of 36, which is 6. Okay, even if you take the negative square root, which is a minus 6 also, there is no problem. Either ways, root 36 is a rational number. Okay, now 3 into root of 81. Root of 81 is a 9. So basically this number is a 27. So 27 again can be represented as 27 by 1, which is a standard form of a rational number. Hence 3 root 81 is a rational number. Okay. Now minus 11 by 8, again very simple. Minus 11 and 8 are both integers. Therefore this is a rational number. Is it represented in the standard form? It is in the lowest form where there are no common factors and the negative sign is in the numerator. Therefore this is perfectly represented in the standard form. Okay. Now 0.95. The same rule applies as in minus 3.5. So 0.95 I can represent it as 95 by 100. Now you know that 5 is a common factor. The cancelling out the 5, you get a 20 here and you get a 19 here. Thus 0.95 is a rational number whose lowest form is 19 by 20. Okay, or the standard form. Minus 1. Minus 1, it is an integer which can be represented as minus 1 by 1. Therefore, this is also a rational number. Okay. 0. I don't need to tell you 0 is an integer. Therefore, it is a rational number. But 1 by 0 is not a rational number because the denominator cannot be a 0 at all. Fine. Root of 2. Now, this is something that you need to be careful about. When I said the root of 36, you were able to find the square root. That is because 36 is a perfect square. But what about root of 2? Root of 2 cannot be a rational number because there is no proper value for root of 2. Okay, and 2 is a prime number. The square root of prime numbers are always irrational numbers or not rational numbers. So please remember this particular point. Whenever you have a prime number inside a square root and somebody is asking you, is this a rational number? You can straight away tell that, no, this is not a rational number because the square root of prime numbers are not rational. Same logic, this is also not a rational number. Okay, now minus 0.675. It is a negative number. It is a decimal. Going by the same logic of 0.95, I can write this as 675 by 1000. Cancel out the common factors and put it in the standard form. I am leaving it to you to solve this particular number. Okay. Now, 47. A very normal number. It can be represented as 47 by 1. Thus, 47 is a rational number. Now, minus 111. Again, I am not repeating. It is again a rational number. Minus 8 by 80. Numerator and denominator are integers. Hence, it is a rational number. Sorry. Is it the lowest form? Definitely not. 8 is a common factor. So, this becomes minus 1 by 10. And the negative sign is in the numerator. Denominator is left as positive. Now, it is in the standard form. Now, what are we? Okay, root of 5. Again, you know that 5 is a prime number. You can straight away say that it is not a rational number. We are done with everything except this particular number 0.912345 dot dot dot. What do you mean by dot dot dot? The number doesn't stop there. It goes on. It is never ending. That is the meaning of dot dot dot. Such numbers are, and one more thing that you can notice over here is that none of the digits are repeated. They're random digits. Just digits are put together. If you have a number like 0.3535 dot dot, you can see that there is a pattern over here. In this case, there is no pattern. Any number that goes on after the decimal without a pattern is not a rational number. Now, the reason for it is something that you will study in the higher class. But for now, please understand that any non-stop decimal without a pattern of repetition is never a rational number. Okay, I'll give you a few more examples over here of this kind of number so you get a clear understanding of what I am talking about. I have written here 3 numbers, at least one you are very familiar with. The last number is a random number that I just wrote it, but the first 2 numbers are renowned mathematical numbers. The first one you keep on using everywhere. It is a value of pi. You know that the decimal value never ends. We are only using the approximation, which is 3.14. Okay, this number is not a rational number. It is called as an irrational number. Now, this particular number is called as the golden ratio. Now, the details of golden ratio, if you Google, you will get a hell lot of information. This particular value is always approximated to 1.618. This is a number that is used to assess the beauty of many articles, including our face. Okay, so this golden ratio is also an irrational number. Now, this is just another random example of a number that is not rational. No pattern, the numbers does not stop, it goes on and on. So, I hope you are clear with why these numbers are not rational numbers. There is no way in which we can represent these numbers in the form of P by Q, unlike a number 1.5 which can be represented as 15 by 10. Then we can reduce it into the lower form. Clear? So, before moving on to the properties of rational numbers, let us do a small recap of whatever we have studied so far. We learned about the definition of a rational number. We learned that the numerator and the denominator can be integers, but the denominator cannot be a 0. If there are rational numbers, there are a few numbers which are called irrational numbers. We learned how to identify those irrational numbers and how to identify a rational number. We saw a few examples too. Now, in order to represent a rational number in the lowest form, we need to cancel out the common factors, from the numerator and the denominator. Also, we learned that in order to represent the rational numbers in a standard form, first we need to bring it down to the lowest form and to put the negative sign in the numerator instead of the denominator. Okay, now we learned that the square root of a prime number cannot be rational. Every integer is a rational number. Okay.